Hello, my name is Sakuragi from Hokkaido University, Japan. Today, I will talk about diving classification of lactating northern fur seals based on three-dimensional movements. The marine environment is a three-dimensional space, so it is important to understand the marine ecosystem and environment three-dimensionally. Marine mammals are one of the top marine predators. They change their behavior depending on prey distribution to forage efficiently. Prey species are also affected by changes in the marine environment. For example, planktons, temperature, salinity, and some chemicals. Therefore, foraging behavior of marine mammals can be a good indicator of changes in the marine ecosystem. The knowledge of the foraging behavior of marine mammals in their three-dimensional environment is important for understanding the marine ecosystem and environment. During summer, female northern fur seals give birth a single pup, and lactating fur seals begin the cycle of feeding at sea for between half day and 7 days, and nothing on land in 1 or 2 days. Northern fur seal females often travel to distant foraging areas for several days to transport energy back to their pups. This travel is called foraging trip. During foraging trips, it is known that they exhibit various behaviors to forage efficiently. For example, diving, foraging, traveling, and resting. This figure shows time depth profile of a northern fur seal during foraging trip in the Kuril Islands of Russia. During daytime, they rested at surface like this photo. On the other hand, they dove at night to forage mesopelagic fish and crustaceans which move up to shallow depths. Focusing on one dive, there were dives that differed in maximum dive depth and dive duration, as seen in these figures. Upper one is a dive with short duration and shallow maximum dive depths. On the other hand, lower figure shows a dive with long duration and deep maximum dive depths. As seen here, it seems that northern fur seals have several dive types. However, it is unclear how many dive types fur seals have and what purpose each dive type is. In some studies, dive types of marine mammals have been considered to associated with different purposes. For example, look at the left time depth profile. This dive includes small ascents and descents or wiggles during the bottom phase, and this behavior is considered to prey-parasite activity. Therefore, this dive type is considered to be a foraging dive type. The middle dive type is a shallow and short dive duration, and this dive type is considered to be a transiting dive type. The right dive example includes gliding behavior on descent, and this dive type is sometimes considered to be a resting dive type. Northern fur seals also appear to perform several dive types. Additionally, because they dive in a three-dimensional space and these simple time depth profiles do not capture the three-dimensional aspect, understanding the three-dimensional diving behavior can provide us with additional important insights into their foraging ecology. Therefore, the object of this study is classification of northern fur seal dives by using three-dimensional diving data. During the breeding season of August 2006, 3 female northern fur seals with their pups were captured on Lobzhiki Island, Kuril Islands, Russia. Seals were equipped with 2 data loggers, a GPS data logger and a 3D data logger. GPS data loggers were programmed to record GPS position every 10 minutes. 3D data loggers were programmed to record depth, temperature, swim speed, tree-axis magnetisms, and tree-axis accelerations. Data loggers were glued on the back and head of the animal. From these data loggers data, we reconstructed three-dimensional diving behavior. Then we calculated 24 variables of each dive referenced to previous studies. From time depth data, each dive was divided into three phases: descent, bottom, and ascent phases. We also got maximum dive depth, dive duration, descent and ascent change rate, and so on. From acceleration data, their activity and posture was determined. Fossils swim by using forelimbs like birds. These behaviors were determined for each dive phase. From three-dimensional diving path data, we got horizontal and three-dimensional displacement and linearity in the whole dive and at bottom phase. Next, we conducted factor analysis to reduce 24 variables and identified 5 key factors. Last, we conducted hierarchical cluster analysis by using 5 factors and identified dive types. Northern fur seals mainly dive for foraging, so at first we checked their foraging behavior in each dive. For example, in the time depth profile, variance of vertical displacement at bottom phase. When their pitch angle changes from negative to positive or vice versa for over 60 degrees within 5 seconds. This behavior is called a vertical turn and was considered to be one of the prepositive behaviors. We checked for these two foraging behaviors and compared in each dive type. This is the result. We analyzed 3086 dives from 3 seals. From hierarchical cluster analysis, dives were classified into 5 dive types. Cluster A was the most numerous dive type, and Cluster D was the second most common dive type. This table shows the mean value plus minus the standard deviation of foraging behavior, variance of vertical displacement, and the number of vertical turns. Dive type A, B, and C were higher than dive type D and E. Therefore, dive type A, B, and C were considered to be foraging-related dive types, and dive type D and E were non-foraging dive types. In order to attempt to assign a purpose to the non-foraging dive types, we compared type D and type E to type A, the most common foraging-related dive type. Dive type D was characterized by short dive duration, no bottom duration, and a shallower body angle in the ascent phase. These characteristics were similar to the V-shaped dive type observed in other pinnipeds. This suggests that this dive type was used for transiting. Next is dive type E. This dive type was characterized by slow speed and fewer number of strokes in the descent phase. These characteristics suggest gliding behavior. Other diving pinnipeds, for example, northern elephant seals, hooded seals, and baikal seals, exhibit gliding behavior. This behavior can be used for energy saving. Therefore, we consider this dive type to be a resting dive type. Next, I discuss the three types of foraging-related dive types. Three types of foraging-related dive types were different in linearity and duration of the bottom phase. Type A and B dives were more sinuous than Type C dives. Type B dives had the shortest bottom duration of the three foraging-related dive types. From these characteristics, we named Type A, B, and C dives as tortuous foraging dive type, short bottom foraging dive type, and straight foraging dive type. Tortuous foraging dive type shows the highest foraging activity, for example, vertical turns and variance of vertical displacement. And this dive type was the major dive types of northern fur seals in this study. Tortuous movement shown in this foraging dive type is observed in foraging behavior to patchy distributed prey called area-restricted search. Area-restricted search is a foraging pattern in which a predator responds to an intake of food by slowing down its movement and remaining longer in the most recent located prey patch. Major diet of northern fur seals in this island is mesopelagic species such as northern smooth-tongue and cephalopods. These species are usually distributed patchy. Therefore, tortuous foraging dive type is foraging dives for their prey. On the other hand, straight foraging dive type didn't show tortuous swimming paths and suggests that its dive type is for searching for prey or foraging on solitary prey. Seabirds and some fishes exhibited straightly foraging behavior to search and foraging prey. Therefore, the three foraging dive types of northern fur seals may be performed depending on their prey distribution around fur seals. Additionally, tortuous foraging dive type was continuous. This figure shows time depth profile and dive types. In this figure, the tortuous foraging dive type was performed continuously. It was considered that because mesopelagic prey species which northern fur seals usually feed aggregate in large numbers and make large-scale aggregation near the surface at night. These results suggest that northern fur seals may exhibit continuous tortuous foraging dives when they find a large and high-density prey patch. This is the first study to classify three-dimensional diving behavior of lactating northern fur seals and find differential dive types of foraging and traveling tactics. We classified 5 dive types, and there were not only foraging-related dive types, but also transiting and resting dive types. In foraging-related dive types, there were straight foraging, tortuous foraging, and short-bottom foraging dive types. Continuous tortuous foraging dive type would represent large-scale and high-density prey distribution. This result suggested that northern fur seals would change dive types depend on the situation like prey distribution or marine environment. In the future, of course, it is needed to check dive types against prey distribution and marine environmental data, but foraging behavior of northern fur seals may be used to indicate prey distribution and marine ecosystem changes. Thank you very much for hearing my presentation.